It's such a dad thing to do. Is just slap your like over exaggerate. Oh, that's that's some good coffee. It's like nobody really does that. But back to anatomy here. So today in this episode, we're going to discuss factors that affect the rate of a chemical reaction. So we haven't surpassed chemistry yet, and we haven't because this is a really exciting topic we're going to discuss today here. So factors that affect chemical reaction are the concentration of reactants, temperature, amount of activation energy, what the hell is activation energy, and presence of a catalyst, and also pressure. But first, let's get to the reactants. So if you increase the concentration of reactants, you increase the rate of reaction, and vice versa. Decrease the concentration of reactants, decrease the rate of chemical reaction. So analogy for this, think of if you increase the amount of cooks that are working at a restaurant, you're going to increase the amount of food that can be made, and vice versa. If you decrease the amount of cooks at a restaurant, you're going to decrease the amount of food made. So pretty straightforward when you really think about these concepts. They do make sense, and a nice parallel like this should make that eureka type moment, that type moment there. We all got that light in us, we really do. But also, temperature affects the rate of chemical reaction. So increase the temperature, increase the rate of reaction. Decrease the temperature, decrease the rate of a chemical reaction. So an example of this is think of cooking an egg on a stove. We've probably all have, or personally, or have watched somebody cook an egg on the stove. Hotter the temperature, egg's gonna crisp quicker. Lower the temperature, egg's gonna take longer to cook there. So pretty straightforward as well. Increase concentration reactants, increase the rate of reaction. Increase the temperature, increase the rate of reaction. Vice versa, vice versa. And now third factor that affects the rate of chemical reaction is the amount of activation energy. So activation energy is just pretty much a fancy word of the amount of energy required for a reaction to occur. So it's the amount of energy required to reach an activated state. An activated state is a reaction must reach an activated state to occur, essentially. So we're going to talk about this in a few moments here in depth, but I would Google an energy graph to have that in front of you to get a better idea of what we're talking about here with the activation energy listed in activated state. But activation energy is essentially energy required to start the reaction. So every reaction on the planet of reactions on the planet of in the universe, I'm assuming the universe actually requires activation energy, so the energy required to start a reaction. So if you increase the activation energy, it takes more activation energy that needs activated, you decrease the rate of reaction. If you decrease the activation energy required, you increase the rate of reaction. So as mentioned, reaction must reach that activated state. So activation energy, it's activated. This is the activated state. It needs to reach that activated state before it can go to the other side of the reaction, whether it be exothermic or endothermic, which just look up pictures of those. I really don't. It's tough to kind of draw it out. If you could just Google a picture of an endothermic reaction energy graph, exothermic reaction energy graph, it's going to make much more sense. And an endothermic reaction will absorb energy. It'll have more energy in the products than the reactants, and exothermic pretty much vice versa. It releases energy, so the energy in products is going to be greater than the energy in the reactants because energy is released there. But think of the amount of activation energy as this example. So the larger a mountain, the more activation energy required. It's going to take longer to climb that mountain. So more activation energy, decrease the rate of reaction. But if it's a smaller hill, less activation energy, it's not going to take as long to climb that hill there. So the activated state is the peak of the mountain. It allows to climb down the mountain, but the larger the mountain, more activation energy, decrease the rate of reaction. Smaller the mountain, smaller the hill, it's much easier to climb, so you're going to increase the rate that the hill's climbed or increase the rate of the reaction there. So that's amount of activation energy there. Just a reminder, please look up that energy graph. It'll make much more sense. Like, what's this guy talking about? Hills, mountains. It'll click whenever you see how the graph is drawn of where energy's transferred from and into there. Also, presence of a catalyst will affect the rate of a chemical reaction. So, in biological systems, catalyst is called an enzyme, and this ties into the activation energy. A catalyst will decrease the activation energy required, which will increase the rate of the reaction. So, a catalyst or an enzyme, at the end of the day, increases the rate of the reaction because it makes that hill smaller. It goes from a mountain without a catalyst to a little hill with the catalyst, which makes the reaction happen much, much quicker there. And then, so catalyst, yeah, it reduces the height of the mountain so it can be climbed quicker. And just as a little extra reminder, endothermic reaction, absorb energy, endo within, exothermic, exo exit, releases energy there. So there's two different types of graphs. They do differ in the way they're formed there, but check that out online. Also, last but certainly not least, factor that affects the rate of chemical reaction is the pressure. Increase the pressure, increase the rate of reaction. Decrease the pressure, decrease the rate of a chemical reaction. So think of you or your family members may have an Instapot pressure cooker, or the more pressure, and in this case, obviously heat with the pressure cooker, but more pressure applied to the chicken, to whatever you're cooking, the quicker whatever you're cooking is going to be cooked. So if you increase the pressure, it's going to happen cook faster. If you decrease the pressure, it's not going to cook as quickly. And same with chemical reaction. Increase the pressure, increase the rate of reaction. Decrease the pressure, decrease the rate of the reaction there. So factors that affect the chemical rate of a chemical reaction, boom. Concentration reactants, increase concentration reactants, increase the rate of reaction. Temperature, increase the temperature, increase the rate of chemical reaction, and vice versa. Activation energy, this one's the inverse, so increase the activation energy, decrease the rate of reaction, decrease the activation energy, increase the rate of reaction, because there's less of a hill compared to more of a hill you have to climb. And presence of a catalyst, so a biological system, an enzyme, decrease the activation energy required is what a catalyst does, which increases the rate of the reaction there. So just think of a catalyst as making that hill or mountain into a small hill there. So there's less activation energy, which increases the rate of that chemical reaction. And then the pressure is the last factor that affects chemical reaction rate. Increase pressure, increase rate of chemical reaction. It's a tongue twister when you say these quick. Decrease pressure, decrease the rate of the chemical reaction. Any questions? Okay, no, good. No, but seriously, if you have any questions, type them in the comment section here, and we'll get it sorted out. These analogies are to help all of you understand these concepts a little bit easier. So whenever you really do think about them in depth and look at it somewhat objectively, or just try to draw different parallels in life, it all does make sense. Like, oh, okay, if you increase the number of cooks working in a restaurant, you're going to produce more food, and it does translate over to chemistry and so on and so forth. So that's a beautiful thing about the human body. Beautiful thing about analogies is there's parallels or connections that can be drawn, and we'll see you back here soon. Bye buddy, hope you find your dad.